Every year, more than 1,000 people in all walks of life are killed, and more than 30,000 are injured in electrical mishaps. Now, we're all familiar with the great things electricity can do for us. But to use it safely, it helps to know what it is and how it works. Let's start with some terms that can help protect us from electrical mishaps. Conductors are materials that let electricity flow through them easily. Most metals are good conductors. Some examples are silver, copper, gold, aluminum, mercury, and iron. Water is another good conductor because it contains dissolved salts and minerals. And guess what? Our bodies are about 70% water, making us good conductors too. On the other hand, insulators are materials that hold back the flow of the electric current. They're sometimes called non-conductors. Some good insulators are rubber, plastic, wood, glass, and ceramic. For example, the outside of this extension cord is rubber, a good insulator. On the inside is copper wire, a good conductor. The electricity flows through the copper wire and the insulator keeps it there, unless it's damaged. It's important to remember that certain conditions can cause insulators to become conductors. For example, an insulator such as this clean, dry 2x4 will become conductive if it's wet, dirty, painted, varnished, or treated with preservative. Fuses and circuit breakers are protective devices that stop the flow of electricity when it reaches a dangerously high level, as in a short circuit. Fuses have a metal filament that melts, and circuit breakers automatically disconnect the power. Circuit breakers and fuses help protect equipment and prevent fires, but they won't protect a person from getting shocked. Ground fault circuit interrupters are another type of protective device. They can be in a portable cord like this, or in outlets. Ground fault circuit interrupters, called GFCIs, detect very small changes in current and almost instantly stop the flow of electricity. One of the most common electrical terms is voltage, which is the force that moves electrons in the current. 120 volts is found in typical wall outlets and in some industrial equipment and lighting. Most electrical fatalities involve 120-volt circuits. You also might work around equipment that uses higher voltages, such as 240, 277, or 480 volts. High voltage circuits such as these are especially dangerous. The amount of electrical current is measured in amperes, usually called amps. It's important to remember that the greatest danger is from the amount of electrical current, the amps. In fact, less than 1/10 of an amp can kill a person. There are two types of electrical current: alternating current, called AC, and direct current, called DC. Alternating current is produced at electrical generating plants and is distributed to our homes and businesses. It's called alternating current because the current rapidly alternates back and forth in a circuit. Direct current flows in only one direction. It's the type of current produced by batteries. Direct current can create hazards. For example, vehicle and forklift batteries can produce dangerous sparks capable of igniting gases and causing an explosion. Another important electrical term is ground. Objects are grounded if they're connected to the earth with a conductor. Electrical tools and equipment can be grounded through the ground prong on a cord. The ground prong is connected to a separate grounding wire inside the cord. If there were a short circuit, the surge of electricity would flow through the ground wire and into the earth, rather than into a person or equipment. Now, static electricity is an electrical charge that builds up in a variety of objects, ranging from storm clouds to people. Static electric discharges can range from a tiny spark with very little current to a bolt of lightning carrying several 100,000 amps of current and several 100,000,000 volts. But even a tiny spark can be dangerous in work settings with explosion hazards in flammable liquids. For this reason, during the transfer of fuel or flammables, containers are first grounded with a bonding cable before transfer. This helps prevent the buildup of static electricity and the release of dangerous sparks. There are plenty of other electrical terms, but the information we've covered is an important step in protecting yourself from electrical mishaps. Staying alert for hazardous conditions in our surroundings is another way to protect ourselves from electrical mishaps. For example, watch out for loose, missing, or hot covers, switch plates, or outlets. Defective or exposed wiring and overloaded circuits are other common hazards. Report these conditions to your supervisor so they can be fixed. And if you find these situations at home, have them fixed. Other hazards, such as loose, exposed, or cracked wires, may be found in walls, ceilings, and crawl spaces. These spaces are often cramped and poorly lit, which just increases your risk of injury. To help detect any hazards, it's important to use good lighting in the work area. Personal protective equipment is also essential. If you're working above you, use safety goggles to protect against falling debris. Cutting into walls can also be dangerous due to the risk of cutting electrical wires. To locate hidden wires, you can review blueprints, as-built drawings, or use a circuit tracer. If you're operating a powered lift or a crane, or if you're carrying conductive materials, remember to check above you for hazards, such as overhead power sources. If you're going to be doing any work around electrical sources, remove conductive items such as watches, jewelry, and even metal belt buckles. Now let's look at an incident involving a potential electrical hazard that we find all around us: water. Water and electricity simply don't mix. When combined, they create a dangerous hazard we should be alert for. Make sure your hands are dry when handling electrical tools, cords, or equipment, and use the switch to turn a device off and on. Usually, fiberglass or wood ladders are best to use around electrical sources, but moisture causes them to become conductive and dangerous to use. Water on the floor can be more than an electrical hazard. It can also be a serious slip and fall hazard. And even wet gloves or wet footwear can increase your chance of being shocked.
A friend of mine was working at the end of the day on a wet, damp ground, and he reached into a base to pull some wires out to work on, and as he did so, as he reached in there, he was electrocuted. And there was someone there that was trained in CPR and first aid that started on him right away, and it didn't make a difference. He didn't make it.
Distractions are another hazard that can kill. Remember the scene at the beginning of the program? Not only was the man with the conduit distracted, the control panel had also been left open and unattended. Staying focused on your work, your surroundings, and your safety is your best protection. Finally, the wrong frame of mind can cause hazardous behavior, such as taking shortcuts and being inattentive. The right way? We should keep our attention focused on our work, avoid shortcuts, and make a commitment to work safely. Simple mistakes can result in tragic consequences when electricity is involved. For instance, several common yet serious mistakes contributed to that mishap. First of all, he didn't turn off the electricity. Next, he wasn't wearing any personal protective equipment. Also, he was using a tool that wasn't insulated, and he was using an aluminum ladder while performing work near a possible electrical source. Let's look at the right way for this job to be performed. Go to the source, turn off the power. Using a breaker lockout device will prevent the power from being accidentally turned on while you're working. In fact, there are many situations where regulations require that the power be locked out by a person authorized to perform lockout. Next, use your personal protective equipment. In this case, safety glasses with side shields. If you're working around potential electrical sources, there should be no metal in the glasses. Wearing leather or insulated gloves will give you added protection. Before you actually start work, use a circuit tracer or meter to verify that the power is on. Next, using insulated tools will help protect you from electric shock. Insulated tools are designed to protect against shock up to the voltage level shown on the tool. If you're using electric hand tools, double insulated tools will give you the greatest protection. Finally, if you're working near any potential electrical sources, it's best to use a fiberglass or wooden ladder. But make sure it's dry, clean, and unpainted. Now see if you notice the mistakes in this next scene. Several common mistakes contributed to this mishap. First of all, he had liquid in his work area while using an electrical tool. Whether it's water on the floor or in a cup, water and electricity have to be kept away from each other. Keep your work area dry and avoid bringing liquids into the area. Let's look at some other mistakes. Not only was the insulation on the extension cord damaged, but he was also using a cord that had the ground prong removed. Before starting work, select a high-quality extension cord that's in good condition, that's rated to handle the equipment being used, and has an intact ground prong. Select a cord that's been approved by an independent testing laboratory. Avoid using adapter plugs because they eliminate the proper ground that will protect you from shock. Using a cord with a built-in ground fault circuit interrupter will also protect you from shock. Another dangerous mistake is turning the power on and off by plugging and unplugging a cord. This can cause sparks, create a shock hazard, and damage the cord and outlet. We've seen how important it is for our safety that we prevent mistakes like the ones we've seen. But it can be just as important to know what to do if an electrical mishap occurs. Knowing what to do and what not to do if you come across an electrical mishap like this can mean the difference between life and death for the injured person and yourself. First of all, don't rush into the situation. You could be injured or killed. If the person is still being shocked, don't touch them. You could get shocked too. If you can, quickly shut off the power and call for emergency medical help.
There's been an accident in Warehouse B.
If you can't turn off the power, use a dry, clean, non-conducting object to push the person away. Then call for emergency help.
I'll go get some help.
If the person is no longer being shocked, call for emergency medical help immediately or get someone else to call. If possible, turn off the power source. Try to calm the person and keep them still until help arrives. Don't give them water because it could cause a stroke. If they're bleeding, don't touch the blood. If you're the person being shocked and you can't let go, let your knees collapse. The weight of your body can pull you away from the source of the shock. Of course, the safety practices that we've talked about will protect us at home as well as on the job. No matter what job you're doing and whether you're on or off the job, it's important that you're qualified and authorized to do the work. If you have questions, check with your supervisor or hire a qualified electrician. Remember, most electrical fatalities involve 120-volt circuits, like we have in our homes. So give electricity the respect it deserves, both on and off the job. Your safety, the safety of your family, and the safety of your coworkers depends on it.